know our pillar strength from Solomon's approach. He says the pillar strength is this. And he wrote this. So in the question, you know the all body thickness. And then, so if we are using the all body thickness as the height, okay, the H here, and then the width of the pillar as this. What will this be? So we are calculating for just the pillar, We are not calculating for pre-mining stresses now. Okay, it is not the pre-mining stresses we are calculating. So we are just within the stope and we are mining the ore body. So with the ore body, if we are mining all the 2.5, the pillar height, the height of the pillar is this. So don't confuse this H here with the Z you see in, or the H you see in this formula. They are two different things, please. This H here is representing the height of the ore body. And once you want to mine the entire ore body at a go, that is why the question emphasized that assume full ore body thickness of 2.5. You are taking it all. Then the height of that pillar is going to be 2.5. And then you have your width of the pillar, which is given to you as 5. And so you have your pillar strength, according to Solomon's, to be 8.22 megapascal. Then now you go in for your pre-mining stresses. This is where you make use of your 80 and then your unit weight of the substance. And this 80 here is representing this H, which we usually will represent by Z. And so you have your pre-mining stresses to be 2 megapascals. Then your axial pillar stress. Axial pillar stress is the width of ore, width of pillar, and then width of pillar. So width of ore, which is the room span, was given as 6. You know your width of your pillar to be 5, and you know your width of pillar to be 5. 11 divided by 5 to the power 2. What value is that? You multiply that by your pre-mining stress, PZZ, which is 2 megapascal, this one here. And you have 9. So if I want to compute my factor of safety, all I need to do here is to find out the strength of the pillar divided by the stress the pillar is going to bear. So this is my strength, and this is the burden I have to carry, the cross I have to carry. When they divided, I got a factor of safety to be 0.85. So it means that if we even consider, let's forget about these dimensionless units and express this as a percentage, it simply means that you have 85% chance of safety when you are in the mine or in that particular stope, and you have 15% chance of failure when you are in there. So what that means is when you are down there working, you can have a rock fall on your head. If you are fortunate, you walk out. If you are not, you are blocked in there and you can't come out. So that is So 85%. So are we safe to mine? And according to Solomon's principle, have we satisfied that? Any comments regarding the value we have gotten? Because the question said, calculate if the factor of safety is not guaranteed. So the first question will be, is the factor of safety guaranteed? According to Solomon's. Any comments?
No, it's not.
It is not. Why?
I think the minimum requirement is 1.3, where we are getting 0.85.
Good.
So we're short.
So we expect a factor of safety per his theory to be 1.3, but we have 0.85. So it means it won't work. And the question asks us further to find out what modification can we do. So what do you think we can do if we are not, or we shouldn't mind? What modification can we do? Mr. Benyako, are you around?
Yes, it's around.
Yeah, so what can we do? Our factor of safety is not guaranteed per the calculations we've done and the theories we are using. We expect a minimum of 1.3 and we have gotten 0.85. It means we couldn't even meet the minimum. Should we stop mining? Or what can we do? What modifications do you think we could put in place to help us mine if we are not giving up? Mr. Enu, are you there?
Maybe increase the weight of the pillars.
We should increase the width of the pillars. Okay. Then that means more more or as pillars.
To achieve the factor.
More or as pillars. Okay, that's one of the things we can do. What again? Who else?
Okay, Doc. Can we also get artificial support?
Okay, we can also bring in artificial support to facilitate the stability of the space we are working. That's good. What again? Anyone else? Mr. Ajman, do you have anything to add?
Yes, we can also reduce the span of the room.
The span of the room. Okay, let's try that and see. If we do it here immediately, what can we do? Those suggestions that came up, let's put, if we are to increase the pillar width, so let's make this 6. Okay, so we are going to have 6 plus 6, that's 12, divided by 5 to the power 2 times 2, because this one, we don't have control over this. So what will we have? Those of us with calculators, please point that quickly, let's see. We are changing the pillar width to 6 because someone said we can increase the pillar width. And let's see if we can get our factor of safety.
Doc, 11.52.
That's 11.52, right?
Yes, please.
Okay, so if we increase the pillar width, we are going to get 12 divided by 5 to the power 2, and that was
5-2.
11.52. Then now let's come here. We are putting 6 here. What will we get as this? Let's see whether there will be an impact. You get what we are doing? We are changing the width. We are trying to increase the width of the pillar as one of the ways to see whether this can bring about stability. And someone proposed increase the width of the pillar. So once we are increasing the width of the pillar, it will affect both the pillar strength and the pillar stress. So that is what we are doing. So we've tried it for the stress, and the stress has increased to 11.52. Let's go and check how it will affect the pillar strength too. Anyone? Zero 0.45, 6 to the power 0.45.
I'm getting 9.17 for the pillar strength.
9.17. Okay, so it means still, because this thing, for us to have a factor of safety that is good enough, we should have this being greater than the stress, and still we are not making any visible improvement. So it means increasing the pillar strength here, the weight of the pillar is not working. And someone else also suggested we reduce the width of the pillar. So we did by increasing. So this is what we call sensitivity analysis. So we are trying to see what can happen if a particular component changes. So let's reduce this one to by 1 and have 5 plus 5 over 5. That would be 2. 2 to the power 2, that is 4. 4 times 2, that would be 8. So this will be equal to 8. So let's go and use, okay, and it doesn't affect this one, right? This is not affected. The pillar strength is not affected if we reduce the room of the pillar, the room
Yes.
of the space. Yes. So it means we have 8.22 over 8. We are likely to make a headway divided by 8. We have 1.02. So let's make it 0.3. But at least there have been some improvements. That means if we keep reducing the room, but reducing the room also means forfeiting your all. Right? So those are some of the things you can do. So it says that since we have this less than 1.6, which is redesign is necessary if we are to redesign, because it stated here that suggesting a reasonable design of this, if you want to get the best stability possible, your factor of safety should always be in the middle, which is 1.6. Then it means redesign is necessary. Some of the answers you proposed are here. Reduce the room span, thereby reducing the stress level. Increase the weight of the pillar. We did, it didn't work. Then reduce the pillar and mining height. Okay, that is also nice. Let's go back.
Doc, can we check the first option again where we increased the pillar width?
Okay, so
You know, it looks like when we increased it in the getting the pillar stress, the average pillar stress, we only changed the numerator, the pillar width at the numerator, but the denominator, we didn't change it.
I don't know whether the person who points did or not. So we are going to have that of 6 plus 6 over 6, right?
Yes.
So that would be 2. So again, we are going to get 8. Isn't it?
Yes.
That would be 8. So it means that this one would change. So we
And
are
we
going to
have
have
9.17.
9.17 over 8. Ah, Allah. That is nice. 9.17 divided by 8. Somewhere. 1.15. That is what I got here.
Yes.
So it means there have been some improvements when you change the width of the pillar. So you see, thank you for proving the points here for us. Then the mining geometric parameters can be varied so as to obtain this. So you have to change certain parameters. So these ones are for us to go and try. But remember, you know the height of the room. What factors do we consider when we want to choose the height of the room? Because I think you can't just vary those ones to anyhow, because you may be using equipment, isn't it? You may even want to consider the height of men in there. If you have some Goliaths there who may be working there, their height. So you have to consider all these factors. You'll be using ventilation tubes in the stove. So it should be the space or the height should be such that when you have all these things in there, you still have enough room to work. So 2.5, you changing these values, what can you come out with? So you have an instance where the span is reduced, the width, the pillar width is maintained, the height is maintained. You have this change to 6, you have the width change to that, the height maintained. You have this and that and that. So this is something for you to try on your own when you leave class. Go and work them. Else you might see them somewhere and they will come with answers and you might not know. You now have to work them yourself. All right, so let's move on. And I think we are through with our lesson and our program for this week. So as usual, if there are any concerns and comments regarding the class and what you think we can do better going forward, I'm open for that. Any comments regarding the class so that going forward, I can make